Okay, let's just dive right in. We're talking about the year 2026. And it's not just another year for AI. It's a real inflection point. This is the moment where computer vision stops being a tool that just looks at the world and starts becoming an active participant in it.
So what does that really mean? Well, think back just a few years ago. We were blown away when an AI could simply see a cat in a photo. And look, that was a huge deal. But by 2026, that's kind of child's play. The new game is an AI that does. It doesn't just see the cat, it understands what that cat is about to do, it predicts where it's going to go, and it can actually take action based on that. We've jumped from just passive recognition to active agency.
And this leap, this jump from seeing to doing, well, that's what's defining this entire new era of computer vision. We're building systems that are now active agents in our world.
But how in the world did we get here? What's happening under the hood that makes all this possible? All right, let's take a look inside this new AI brain and really understand the core tech that's driving this whole revolution.
The big thing to get here is that the walls between different kinds of AI have basically just crumbled. We used to have one model for language, a different one for images, but by 2026, they've merged. This table here shows how different foundations are being combined into these unified systems that can process pretty much any-to-any information.
So what does any-to-any even mean? It means these new systems, these universal encoders, are multi-sensory. They're not just looking at text and images anymore. They can reason across 6 different types of data all at once, including video, audio, and get this, even depth and thermal data. This gives them a much, much deeper, more complete understanding of the world.
And that deeper understanding, it's completely changing 3D vision. We're moving on from technologies like NeRF, which were awesome for making these beautiful 3D pictures from really clean images. The new frontier, with models like ShapeR, is all about generating true, geometrically perfect 3D shapes from messy, casual video clips. The kinds you just take with your phone. It can build a full 3D model, even of parts of an object it never actually saw.
Of course, all of this power needs some serious hardware muscle. We're in what they're calling the Yoda scale era now. This table shows the new heavy hitters from all the major players. Platforms like NVIDIA's Vera Rubin, AMD's Helios, and Intel's 18A Edge, these aren't just slightly faster GPUs. No way. They are totally redesigned systems built from the ground up specifically for these new agentic AI workloads.
But the biggest hardware store isn't just in some giant data center. It's probably sitting on your desk. This is absolutely stunning. By early 2026, the combined computing power of all the AI-capable PCs shipped to people like you and me is greater than the capacity of 40 major AI data centers. This is the explosion of edge AI. All that processing is happening right there on your device, which is way faster, more private, and a lot more energy efficient.
So we have the tech, we've got the hardware, but so what? What does this actually change for us? Let's take a look at how this agentic AI is fundamentally rewiring our world. Okay, take autonomous vehicles. It used to take years to painstakingly map every single street of a new city before a self-driving car could even think about driving there. Now, with these vision, language, action models, a vehicle can understand a new city pretty much like a human does, just by observing and reasoning. This has shrunk that deployment time from years down to just a few months. It's a total game changer.
And the scale we're talking about is just mind-boggling. This is not some little pilot program anymore. By the end of 2026, Waymo is shooting to provide 1 million rides per week. This is the real commercial turning point for self-driving cars, and it's happening right now.
Now, in healthcare, the changes are just as profound. Computer vision is now a structural piece of the system. Let's look at radiology. Instead of a first-in, first-out line, AI now acts as the first line of defense. It pre-sorts every single scan, flagging the urgent stuff like strokes or tumors, so a radiologist sees the most critical patients first. This is literally saving lives.
And that's just scratching the surface. This new clinical intelligence is enabling things that sound like they're straight out of science fiction. AIs that can spot diseases just from your posture, before you even have symptoms. Silent assistants in the operating room that track surgical tools and slash errors. And continuous patient monitoring right from their own homes.
This massive technological shift is also creating brand new geopolitical realities. In 2026, one of the most exciting stories in the AI world is the rise of Nairobi, Kenya as a world-class hub. And it's all driven by this focus on what's being called sovereign AI. So instead of just importing technology from somewhere else, Nairobi's ecosystem is all about building AI to solve its own local challenges. The focus is on really practical stuff, like intelligent food systems for its massive agricultural market, predictive security, and developing inclusive AI that actually serves local communities.
Now, whenever you have a technology this powerful becoming this widespread, you know society is going to be racing to adapt. So let's look at the new rules that are being written to try and govern this new reality.
The rise of deepfakes and AI-generated content, well, it triggered a rapid-fire legislative response. In the U.S. alone, 2026 saw a whole wave of new federal laws, like the Defiance Act and the No Fakes Act, all designed to protect people from digital exploitation and basically establish your right to your own digital likeness.
But the challenge here goes way deeper than just spotting fake content. The really tricky part for our legal system is this idea called the liar's dividend. See, when anything can be faked, it becomes super easy for bad guys to claim that something that's totally real is actually fake. And this just fundamentally attacks our trust in audio and video evidence. It's a huge problem we're still figuring out. So, with all this incredible progress and all these new challenges, what's next? Where do we go from here? Let's look at the future of vision and the new frontiers that researchers are just starting to explore.
If you look at the big computer vision conferences like CVPR 2026, you get a sneak peek. The focus now is on 4D vision, that's understanding how things change over time, and on getting these AI agents to work reliably in the wild, not just in some clean lab environment. And crucially, there's a massive push for explainable AI so that we can actually understand why these systems are making the decisions they're making.
And all of this leads to a really profound question that researchers are asking themselves. For years, the path to smarter AI was pretty simple. Just build bigger and bigger models, more data, more compute. But is that still the answer? As we start hitting physical and financial limits, the whole community is asking, what's going to be the next driver of intelligence?
And that really brings us full circle, doesn't it? The ultimate goal isn't just to build a machine that can see. When we look at the state of computer vision in 2026, it's so clear that the technology has grown into something much, much more. It's about integration, it's about action, and at the end of the day, it's about empowering people to solve problems and achieve things we never ever thought were possible.